Okay, so I know the last page was a little bit long, and there's still one more page in the notes for today. This is a performance task type question. So as you're going through and answering the different parts of it, this is going to combine a lot of different skills together that we've learned about so far this year. It says use the diagram at the right to answer the following questions, show all work, and explain your reasoning. So question A says find the perpendicular bisector, find the equation of the perpendicular bisector of the segment that's shown over here on the graph, and it says to explain your method, or explain your method. So that means that we're going to have to describe something about it. So if it's perpendicular, that means that it intersects it at 90 degrees, so it's going to be something like this. And if it's perpendicular, that means that the slopes are opposite reciprocals. If it's a bisector, that means that it's going to intersect that segment at its midpoint. And so we already know we have a formula that we use to find midpoint. So I can find the midpoint of this segment by counting on the graph, but I can also find the midpoint by using the midpoint formula. So let's start by finding the midpoint. In order to find the midpoint of the segment, I need to know the coordinates of the endpoints. So this endpoint is at 30, 150. Notice they're not counting by ones. And then this endpoint over here is at 120, 60. So the formula that I use to find midpoint says that I take my two x's and I add them up and I divide by 2. And then I take my two y's and I add those up and I divide by 2. So to find the midpoint of this segment, I'm going to take 30 and 120 and add them up and divide by 2. And then I'll take 150 and 60 and I'll add them up and divide by 2. So let's see what I get when I do that. It should be right here. Like you can kind of already see where the middle is, but we're just doing the math out to confirm that answer. So the midpoint of this segment is going to be 75, 210 divided by 2 is 105. So 75 is halfway in between 60 and 90, and then 105 is halfway in between 90 and 120. So that is the correct midpoint right there of the segment. I put a circle around it so that you could see where it came from or where it was located on the graph. So if I'm trying to construct the perpendicular bisector of this segment, I could take a compass and go whoosh, 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 and then just find the equation for the line that goes through the middle. But I'm going to choose to find the equation algebraically instead of graphically. So right here, that midpoint is at the point 75, 105. So that's its location. But now I need to do two other things. I need to find the slope of this line, and then I need to ask myself, what would the slope of the line that's perpendicular to it be? So to find the slope of this line, I could use the slope formula. To find the slope of this line, I could also just count the slope on the picture. So I could count how many it goes down and how many it goes across. But just to be consistent, I'll use the slope formula. So the formula to find slope says little m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. When I find the slope of this line, it should for sure be negative because it's going down. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I get negative 90 divided by positive 90. And so negative 90 divided by positive 90 gives me negative 1. So the slope of this segment is negative 1, but I'm trying to do something and find the slope of a line that's perpendicular to that. So if the slope of this line is negative 1, then the perpendicular slope is going to be positive 1 because it's the flip of this upside down, and then you have to make it be the opposite sign. So I'm going to be using this as my slope when I use my formula. So I'm trying to find an equation of a line that goes through this point that's perpendicular to this line. So it goes through the point 75, 105, and the slope is positive 1 because it's going to be perpendicular to that line. That's the slope is negative 1. So when I do y equals mx plus b, put the x, the y in for the y, my m in for my m, my x in for my x, and then the b stays b because that's what I'm trying to find. I get 30. So the equation of the perpendicular bisector of the segment that's given to me on the page, the answer to this question is going to be y equals x plus 30. Remember, the x stays x, the y stays y. The 1 for the slope that I got right here goes in front of the x, so I don't write the number 1. And then the 30 is what I got over here. So this one over here is like the answer to the question. Let's graph it. Positive 30 is right here. And then it says I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And so if you graphed that perpendicular bisector in on your graph, this would be the location of the line that cuts that segment in half and is perpendicular. So all of those would be 90-degree angles now in the middle. All right. The next part says, find the equation of a line that's parallel to the segment but has the same y-intercept as the equation that you found in part A. So for this one, they want us to say, in part A, the y-intercept that I found was, my y-intercept was 30. And if they wanted it to be parallel to this line right here, then my slope would have to be -1. And they want me to find an equation of a line that goes through this y-intercept that has this slope. So technically for this question, you don't have to show any work. Y equals -x plus 30. Because if you know the y-intercept of a line, and if you know the slope of a line, then you don't have to do any work to find the slope or the y-intercept. You've got all you need. And so to graph this, it's going to be hard to fit on the paper. Y equals -x plus 30. It would start right here, and then it would go down 1 over 1, down 1 over 1. It would keep going, but this graph decided to just to graph in quadrant 1. But if you drew the line a little bit longer, it would be over here. The final question on your notes for today says, what is the relationship between the two lines that you found in parts A and parts B? So in part A, we said that this line right here was perpendicular to this line right here. And then in part B, we said that this line over here was parallel to this line over here. And so what the final question is asking us is it's saying, if you compared the third line to the second line, what relationship would they share? So you guys, if these two lines are parallel, and if this line is perpendicular to this line, then it also means that this line is perpendicular to this line as well. So the conclusion that you draw for part C says, in question A, we got y equals x plus 30. And then in question B, we got, let's see. Oh, you know what? I actually misunderstood the question. They didn't want us to answer. No, they did. Y equals -x plus 30. My bad. I was right. So this is the answer that we got in part A. And this is the answer that we got in part B. So this is the line that we drew that was perpendicular to the original one, and this is the line that we drew that was parallel to the original one. And so they want us to compare these two and decide what we know is true about them. So it's good to note that they happen to have the same y-intercept, but that doesn't mean that they can't be perpendicular. It just means that they can't be parallel. Notice how the slopes are opposite reciprocals. So the slope of one is +1, the slope of the other one is -1. And so because of these two things, I can conclude that these two lines are perpendicular. And so this proves one of the theorems that we studied in the notes yesterday. In the notes yesterday, we said that if you have two lines that are parallel, 1, 2, and if you have a line that's perpendicular to one of them, then it means that it's perpendicular to the other one of them. So you can conclude that that line is perpendicular as well. And so that's it for today. Good job.